Hey guys, so today I'll be explaining the experiment number 2. So in experiment number 2 we deal with the router configuration. Over here we have a switch which is connected to the end devices and is connected to the router, which is connected to another router in another network and is connected to the switch and to the end devices. So when we try to visualize this network, we get three main networks. One network is under this from router to end devices. Another network is from 30 network is from router 1 to router 2, and the third network is from the router 1 to this end devices. So as you can see there, the inbound interface is the default gateway for the router, and the outbound interface is the network 30. Similarly, the inbound interface for router 1, if you are moving from left to right, it's 30, and the outbound is 20 network. So over here our aim is to send a packet from one source destination to one source uh, device to the destination device through the network, through the routers, and also simulate the entire flow for the network. Next, we'll be able to uh, access the telnet on this switch from this end device, so that we come to know the concept of telnet access across the networks. Okay, so in previous experiment we only did the connection between two switches in the same network, but now we'll be dealing with two different networks. So over here, first we deal with the configuration of the switch. Okay, so configuration of the switch is uh, totally similar to what we have done before. Okay, the previous experiment. Okay, now we move on to configuration of the router, which is the most important part. So first we add the modules which is written over here. Modules to be added is HW1C2T and HW1CGE. So as we can see, if we click on this router 0, we can see that we have to just switch off this device, drag and drop this module in this. Okay, now the next part is to configure this in the CLI. So for the CLI, we first have the commands. First we go to the enable mode, okay, and then to the config mode. And over here we change our host name to R1 left as we did in the switch. Okay. Now we as we have done in the switch, we enable the secret Cisco for the entry authentication. Then we configure the line console 0, and we configure the password Cisco during the login. Similarly, as we have done in the switch, we access the telnet and by using line VTY04 and allow it up to 5 virtual devices. We set the username as in my experiment I have written it as Adit, so I'll just change this code. In my experiment I performed with username Adit and password Cisco. Okay, and then we encrypt the entire details, and the service password encryption is used for that command. Now the most important thing over here, which is different from the switch, is to set up the interface. So as we can see over here is, as we can see, this gigabit ethernet 0/0 is the interface between the switch and the router, and serial 0/3/0, just hold on. Yeah, serial 0/3/0 is the is the interface between two routers. So now we have to make sure that both these connections are active and we are able to pass the packets between them. So for that we use the commands. First we go to the interface gigabit ethernet 0/0. Then we go to no shutdown. So what this no shutdown does is make our connection active. So now the connection between the switch and the router is active. The next step is to assign the IP address. So for our router, we assign the IP address at 10.1.1.1, 10.1.1.1, and 255.255.255.0 is the default mask. Now this 10 point, I'll just show you. Yeah. So over here, as you can see that for gigabit Ethernet 0/0, the IP address is 10.0.0.1. Okay. So this is we have assigned 10.0.0.1 which is not there in the code, but this is the inbound IP address over here, and not the IP address between the routers. Okay, so now we have kept this as 10.0.0.1. Okay, and then we end this, and now we go to the interface serial 0/30/0. Okay, and we again go to the no shutdown command, and over here the interface change state to down. So it now currently it is in the down state. IP address, now we assign the IP address for this interface. Okay, IP address for this interface is 30.0.0.1. So over here, our for our module it becomes 30.0.0.1, and 255.255.255.0 is the default subnet mask. We again use the no shutdown command to activate the link between them, and then we use the clock rate to define the speed. Okay, but it says that it only used for DC interface. Then we use bandwidth 128. Either both of them can be used. It's not necessary to use both of them. And then we use exit. Now the most important thing on this experiment is to understand the IP routing. So whenever, if for example a packet is going from PC0 to PC3, it will follow the route as it will go to PCs. From PC0 it will go to the switch 0. From switch 0 it will go to the router 0. Now our understanding says that from 10.0.0.1 it is supposed to go to 30.0.0.1, but that should not be the case, because if we move to the same router the packets will be dropped and it won't be forwarded. So if we want to hop from 10.0.0 to this next router, we need the IP address of the next router. So the inbound IP address, if we are moving from left to right, becomes 30.0.0.2. So our command becomes IP route 20.1.1.0. This is different from what we have done. Okay, but if we are supposed to do the correct command, then in our case it becomes 10.0.0.1. 255 is a subnet mask, and 30.1.0.0.2 it becomes our destination hop. Okay, and then we exit this interface. Now we do the similar configurations for the router 1, and we now try to configure the hop between 20.0.0.1 and 30.0.0.1. So whenever the packets come from PC3 to switch 1 and to 20.0.0.1 port, then it is directly hop to the 30.0.0.1 interface. Okay, now we'll try to simulate the packet flow from this PC to this PC. So we'll try to simulate this. So as we can see, the PC0 it goes to switch 0. From switch 0 it will read the destination and go to the router 0. Router 0 will again read the packets, and then it will forward the packets to the router 1. Router 1 will read the packets and decide where it has to be forwarded, and it forwards it to switch 1. Switch 1 decides which packet is to be forwarded to which end device, and then as we can see, it's been denied by both this end device because this is only accepted by this one. Yeah, so one more thing, we can also ping the commands from PC0 to PC3 or PC1 to PC3. So let's take PC1 but first of all let's see what's the IP address for this. 20.0.0.5 is the IP address. So in PC1 we go to the desktop, we go to the command prompt, ping 20.0.0.5. yeah, so we are receiving reply. That means the connection between PC1 and to that first end device PC3 is been done. Now we try to access the telnet between PC1 and switch 2. So for that we'll enter the command telnet, but as we don't know the IP address for now, let's go to switch, then physical, config. Let's see what's the IP address. Actually I've written it over here. It is 20.0.0.2. I think it's 20.0.0.2 only. Let's try. If we get wrong, we'll check it over. 20.0.0.2. Yeah. So over here we see that it's asking for the username. So in the Switch configuration, we have used the telnet as Adit as the username and password to be Cisco. Okay. Now we can see that switch write has been activated and we are into the switch write CLI. So by doing this, we can also access the telnet of a switch which is in the other network. Okay. Now we just exit this. So in this experiment, we saw that how the packets are being forwarded from one network to another network, how we set the IP routing between them, and how the networks are divided, and also the telnet access or telnet session from one end device to the switch of another network. Thank you.